Sometimes we see functions in this format. It's a function raised to another function. Currently, we don't have a rule to handle this situation, and actually we don't really need a rule, another new rule to handle this situation, because we are able to take care of this situation using a couple different ways. One way is logarithmic differentiation, some other ways I will also introduce. First of all, I hope that you recognize this type of function is different from this power function and the exponential function. The power function, you have constant as a power, and here this is not constant. You cannot just use the power rule, right? And for exponential function, the base is a constant, but here this base is not a constant, so you cannot just use the exponential rule. Now, how are we going to handle that? Of course, later on we are going to introduce a little shortcut, but before we do that, we are going to focus on a couple different ways. One is the logarithmic differentiation. Let's see how we can do that. First of all, think of this as your y, right? So we are going to use this as an example. 1 plus x raised to power x, so y equals that. If you remember logarithmic differentiation, the first step is to take natural log to both sides. And the reason we take the natural log, because one nice property about natural log is this power here can be moved to the front of this natural log. So that's what we are going to do. This is equal to x times natural log of 1 plus x. Now, we are going to differentiate both sides with respect to x. The left side, you are going to have y prime over y equals. The right-hand side, it's just a simple product rule. So it's the derivative of x, which is 1, times natural log of 1 plus x, plus x times the derivative of natural log of 1 plus x, which is 1 plus x. And then solve for y prime, which is what we are trying to find. The derivative of y is, the y prime is y times the natural log 1 plus x over 1 plus x. And at the end, you don't want to stop here because you want to substitute your y in here, right? To make it explicit. So at the end, we're going to substitute the y back, and then this is the derivative. Okay, so you see that we did not really need a new rule to handle that. We just used the logarithmic differentiation. Now, second method though, which I feel that they are somewhat equivalent, is to rewrite this function. So this is your y equals 1 plus x raised to power x. Rewrite it using base e. We have done this quite for a few times. I hope that you feel comfortable with doing that. And then you do know that we can pull the power of x to the front of this natural log. Now, when we find the derivative of y, we are going to use chain rule here. The outer is e to the u, right? The inner is x times natural log of 1 plus x. That's the inner. And when we apply the derivative of outer is just e to the u, so it will be the same function. And what is this guy? This guy is exactly the same as this guy. And times the derivative of inner, where the product rule comes in. So it will be derivative of x, which is 1 times natural log of 1 plus x, plus x times the derivative of natural log of 1 plus x, which is 1 over 1 plus x. And at the end, replace this with what we begin with, right? So 1 plus x raised to power x times this whole thing down here. They're actually identical. So this is the so-called logarithmic differentiation to find the derivative of this type as the first method. And second method is to rewrite it into base e, and then we use chain rule to find the derivative. Whichever you feel more comfortable with, they should end up with the same thing. Now we do have a shortcut. Let's take a look at these shortcuts. These shortcuts can be actually proved using the either way, actually using logarithmic differentiation or using rewriting it into base e. Either way, you could certainly see that this original function can be written as e to the h of x times natural log of x. And then when you find the derivative of that, it will be e to the u, where your u is, actually I made a little typo there, your natural log of g of x, right? So you're going to use the product rule for the inner function, and then actually when you later on simplify, this is exactly what it is. Now it looks complicated, but let me try to explain that to you. Probably you may prefer this method. Okay, so we do have two different functions, g on the bottom, h as the power, right? So now the first part, so here the first part, you're gonna apply power rule. So think of this as a function. This is your function, and treat this as constant, okay, in the constant. So you have to mentally imagine this as constant. So when you do that, when you apply power rule, so isn't that you bring up the power to the front, right? So which is h of x times g of x raised to the power, you have to subtract 1 from the power. So h of x minus 1 to use power rule. And then because you treat this as a function, so you need to apply the chain rule. So you need to find the derivative of this inner function, so times the derivative of the g. So that's your first part. And the second part, on the other hand, you're gonna this time you're gonna treat this as function and this as constant. Now when you have this scenario, this is constant, this is a function, you are treating this as an exponential. How do you find the derivative of an exponential function? It will be the same function, g to the x, g to the h, times the natural log of the base, which is the g, right? And then because you're treating h as a function, you need to apply the chain rule, so the derivative of h. Basically, this is the first part, you're treating h as constant, g as function. The second part, you're treating g as constant, h as a function. So you apply power rule in the first part, apply exponential rule in the second part. So that's what this, if I have to describe this in words, that's how I would describe it. I'm going to show you how I actually solve this particular equation, that find the derivative of this particular function using this new rule. You can certainly use logarithmic differentiation, or you can rewrite it into base e, and or you can use this very last one as a demonstration. I'm going to show you this method. So here's the first part, okay? First part, so this is the first part is going to be power, which means I'm going to think of x raised to a constant, right? Think of this sine x as constant. So when I apply the power rule, I'm going to say sine of x, move this power to the front, times x to the subtract 1 from the power, times the derivative of this guy, which is happen to 1 in this case, happen to 1, the derivative of x happens to 1. Therefore, I'm not gonna bother to write this out, not necessarily, right? Now the second part is, so plus, this time I'm gonna treat this as a exponential form. In other words, x, think of this as constant, and then think of this sine x as your function, right? So according to the derivative of b to the x, it's going to be 2b to the x natural log of b. So I'm going to do that, x to the sine x natural log of x times the derivative of this inner function, which is cosine x. Okay, so that would be it. That would be it. Now I will challenge you to solve the same problem. Using that way, using the logarithmic differentiation or using rewriting it into base e, and then find the result and compare the result with this result and make sure that they are actually the same thing, the equivalent. Now lastly, just to better help you understand these little shortcuts, I'm going to do one more problem here. So the first part, I think of this as a power, using the so-called power rule. When you use power rule, you treat the power as constant, right? So think of this as constant, and this is a function. Okay, so let's apply this power rule. It will be x times sine x raised to power x minus 1 times the derivative of this inner function, so which is cosine x. Now plus the second step is you're going to switch the thinking. So you're going to think about this as constant, and this is a variable, a function, right? Function. So this time you're going to think of this as an exponential form. The derivative of an exponential form is sine x raised to x natural log of sine x, because this is the base, times the derivative of this guy, but it happens to be 1, so I just write 1. So this is it.